wind that's pushing it. So when I say the velocity of the plane plus the wind, that's what we refer to as ground speed. Okay? So to get the ground speed is found by taking velocity of the plane, this. I'll put Vg is the velocity of the plane plus the velocity of the wind, which are two separate velocities. Okay? Now, let's say in this instance, I've been given the velocity of the ground speed, and I've been given the velocity of the wind. I need to find the velocity of the plane. So how would I arrange that equation so that I got the velocity of the plane by itself?
Velocity of the ground subtract the velocity of the wind.
Right. So the velocity of the plane is equal to the velocity of the ground minus the velocity of the wind. Fair enough? So let's first find out what the ground speed is. So the velocity of the ground speed has to do with the distance and the time that it takes to do it. So it says that you're supposed to travel 300 kilometers in 3/4 of an hour. So the velocity of the ground speed then is 400 kilometers an hour. And that's in a direction northeast. So again, now this question is going to present two options to us. The first option is using the law of cosines. The second option is to use components and solve it. But to begin with, I need to get two things straight. The first thing that I want you to do is I want you to think about this for a second logically. Somewhere on here, I need to fly such that the wind is going to blow me directly back to here. So where do I have to fly relative to this dot right here? Relative to that dot, where do I have to fly in order for the wind to blow me back to where it needs to be? Sorry?
In what direction?
Exactly. And where's the wind coming from? The north. So I have to fly to the north of that dot, and then the wind will blow me down, right? Okay, awesome. And that's exactly right. So basically what I'm saying is I have to fly somewhere up here so that the wind can blow me down here. Now using what I've been teaching you, and just the simple math, is it says I need to draw my vectors as such. Draw the velocity of the ground speed, and then draw the negative velocity of the wind speed. So let's do that. The velocity of the ground speed being 400 kilometers an hour, right? And then I need the negative velocity of 80 kilometers an hour south. So which direction do I have to draw it? Pardon me? I have to draw it 80 kilometers from the this way. So that's 80 kilometers an hour. And in this case, it's north. So then this resultant velocity right here, that resultant velocity right there represents the velocity of the plane. So how far the plane has to fly. Now, in order for him to fly 400 kilometers an hour and into the wind, is he going to have the plane have to be going faster than the ground speed or slower than the ground speed?
Faster.
Faster. So, let's look at it, and we need to just, all we have to do is have that in mind. Okay? We don't need to know that, but we have to have that in mind. Doesn't make sense. Okay? So now, this angle right here is 45 degrees. Using parallel lines, that makes this angle right here 45 degrees. And this angle right here is 90. So what does that make this entire angle right there?
135.
That's 135 degrees. So now I know a side, I know an angle, and a side in which the angle is between them, correct? So what can I use to solve for the velocity of the plane then? I could use my law of cosines. Okay, so let's do that. So VP is equal to 80 squared plus 400 squared minus 2 times 80 times 400 times the cos of 135. That gives me the velocity of the plane.
I got 460.05, or 460.060.
06.
0.
Okay, thanks. Kilometers per hour. And I now need an angle. So this is where we mess up most of the time. That's the easy part. Now we got to figure out the angle. You have to be able to tell me what direction does this plane need to fly now. Okay? So using my law of sines, sine alpha over 80 is equal to the sine of 135 over 460.06. What is alpha equal? Use your calculator to solve this. You know the answer? Blurt it out.
I got 7.063.
7.063, do we all agree? Alright, so how do I explain that direction then? This right now is 7.063. Somebody explain to me, what direction does that pilot have to fly?
East 52, 1063 degrees north.
Very good.
Could you do north? I would have done north. Same. 7.063.
But you know, don't
Why
do
can't I do
that
that?
at all.
No, because you're coming off the ground, right?
This is the angle that, that's the angle right there.
That would be the 7.
That would be north, so many degrees east. So you would have to subtract these two angles from 90 to get that angle right here.
Just do 45 plus 7.063.
No, I would take 90, subtract that value. You don't follow. This 7.063 is from right, it's from here to here.
Oh, so you have to, okay.
You have to,
I understand.
okay, so you have, in order to tell somebody which way you gotta go, you either have to go all the way there, or this one right here.
Okay.
So if
Exactly.
this is 7.063, I add it to 45, and that's that angle right there. So that's east 52 degrees to the north. This would be north, what would this be? 37.937, I think, to the east. I think that's what it is. Okay. So those are the same angle, but you're telling me to go from here to here, or from there to there. Okay? Does that make sense? Okay. All right, there's my solution. So law of sines was not necessary for this question. I could still solve this using components. Does anybody want me to show this using components? Or are we okay with the law of cosines here? Yes, Eli?
It's all pretty straightforward except for how you got the 135 degrees. It's
Okay,
really
let me do that again. Yeah, that's a good question, Eli. Okay, so the pilot wants to fly northeast, right? Yeah? Okay, well northeast is exactly 45 degrees. It's halfway between north and east. Yes?
Yes.
Okay, so this line is parallel to this line, which makes this angle right here 45 degrees. So far so good. Now my other vector, when I draw it straight up from right here,
Oh, I get it now. I'm good.
that creates a 90-degree angle with that axis line right there. So then I add the two together.
Yeah, I just didn't see it at first.
Okay? Good question. Alright? So that's how we're going to add and that. Alright? Everybody okay with this? Anybody want to see the components or not?
Will we have to do the components?
You can do whatever method works. Alright? When you're using multiple vectors, components is the easiest way to do it.
Do you mean the X and the Y?
Yes.
Oh, I do it that way, I would like to see it.
You would like to see it? Okay. So, I'm gonna start it right away here, but I need to add this vector here, okay, with that vector there. Alright? Okay, so, my first vector this is 45 degrees. My ground speed is 400 kilometers an hour. Okay, so somebody take the sine of 45, or all of you take the sine of 45 and times it by 400.
282.843.
8.4.
8.43.
What is it?
8.43. Yeah.
Okay, so that's, and what is that? That's north, right? Yes?
Yeah.
This is also 282.843 east. And then my other one is the wind vector. But because it was the opposite of the, it becomes 80 kilometers an hour north.
Would you have to find two vectors, because there's two going sideways?
What's up?
Can you go back to that other picture? Because there's the the 400 one,
Which is,
that's what we just found.
Yeah.
And then that other top one.
and then this one right here.
Oh,
I'm adding the green ones together.
okay, got it.
Okay, so I get to there, right? So X and Y, I only have the one, 282.843, and that's east. Then I have 282.843 north and 80 north. Okay.
362.843.
That's east, right?
Yeah.
So okay, solve it. Use Pythagoras' theorem. .06. Okay, Okay, kilometers per hour. And find that angle. Opposite, adjacent, tan.
I got 52.06. I like that way better.
The numbers? Same as that.
Yeah, I like that way.
Okay? Again, not needing to know law of cosines, not needing to know law of sines, all you need is right triangle trig. And you can solve these questions every time. If that's what you prefer, by all means, do that. Okay? Mary, you asked this question. Does it make sense?
I think so, I just have trouble getting into it, like how to draw.
Okay, I don't want to go back to that part of it, because that's what I suspect most people had the issue with. Okay, so, Mary said the difficulty with this was drawing it. What's the first step I have to do in all vector questions?
Draw your things again.
No.
Write down,
B equals B.
Jake?
write down the average velocity equals V2 subtract V1.
But I don't have it there. So what do I have to actually write down? My equation. Write down the equation that satisfies it. If it's acceleration, then it's V2 minus V1 over t. That's fine. In this question here, you're going to get more than one question with the airplanes. So you need to know ground speed's equal to the plane plus the wind. Then we need to be able to isolate if we're looking for the plane speed. Maybe we're looking for the wind speed. Doesn't matter. You need to be able to isolate those. This tells you how to draw them. The second step, draw my initial vectors. 1, 2. Okay? Label your initial vectors. And then from there, as long as you've labeled those initial vectors, all you have to do is follow what it says there. Draw your ground one first, draw the negative of the wind second, and then you can do it from there. Okay? But you need to start every question with this guy right here. You have to start with the equations, because the equations tell you how to draw them. Now, if you can look at the question and draw it out without writing the equation down, so be it. But not many people I've met have been able to do that. So to draw it then, draw your individual vectors first. Draw your individual vectors first. But knowing the difference between the plane speed and the ground speed. The plane speed is what the plane would read. It's no different than if you're driving your car and your cruise control set at 100 kilometers an hour and you got a 50 kilometer an hour wind behind you, okay? You're still reading 100 kilometers an hour. But if I'm standing beside you with a radar gun, you could be moving 150 kilometers an hour, in theory. Of course, it doesn't work that way, but in theory. You will not be going 100 kilometers an hour if you've got a tailwind of 50 kilometers an hour. Just the same as you are not going 100 kilometers an hour if you're going into the wind. The wind is going to slow you down, but your speedometer is reading 100 kilometers an hour, so you think you're doing that speed. You're not. The wind is affecting it, right? The same thing happens with an airplane. An airplane, when you travel out out west, the trip time to go from Regina to Calgary is not the same as Calgary to Regina. Why?
Wind.
Hey?
Wind.
Wind. The prevailing winds. That changes your time. And you can change your time by 10 minutes on a plane ride from Regina to Calgary. Alright? So, my point to this is your ground speed is the speed that you would look up and see the plane going. The plane speed is the speed that the plane actually reads itself. The pilot's reading it as I'm going this speed. And then the wind speed, of course, just affects it. Okay? So we think that when we draw all of these out, we think that the wind speed affects it entirely the same way. So if you have a 50 km/h wind from behind you, it's blowing you 50 km/h faster than what you're going. We know that's not the truth. But in physics, we do it in theory. Okay? Alright? Anything else that you want? I'm giving you an assignment for the weekend. You need to know these questions. Those 4 questions. So we've got to make sure that we get through those questions on 109 today. And you need to be into that review sooner than later. Alright?
I have one last question.
Yes, Cole.
I go back to like the original one where, yeah, that one. How did you get, when you did the top left, I don't know how you got that number.
This?
Yeah,
The law of sines?
right, but like, since that's not how I put it in my calculator, what's the first?
Or you want to know how to put it into your calculator
Yeah.
properly? Okay. I would, okay, just a second, Cole. I'll set this up different for you so I can, so I've got the sine alpha over 12 equals sine 30 degrees over 6 needs to be 20. Okay? So to keystroke this into your calculator, second sine, which is that, okay? But I have a bracket, 12 times sine 30. This should have brackets, it maybe doesn't. Divided by 20, and then close that bracket and hit equals.
17.45.
Okay, so let's go back and let's try this one again. So you need second function sine,
Right.
80 times the sine of 135,
Okay.
divided by 460.06.
Yeah, I got it.
Okay? Alright. Any other questions today? It can be about this, can be about any of the other questions.
Okay, so when a cop does you his little radar gun,
Yeah.
it's the speed that your car is, right? Not with the wind, or you said it is with wind.
The wind will have an effect on the vehicle.
So if I got stopped, could I be like, well, it showed that I was going 110, the wind was affecting it, and fight it?
You could, yeah.
That's good.
Yeah, but you're still probably not gonna win that fight.
But you're already 10 kilometers over the speed limit.
Yeah, but that's not. I think they're okay with 10. That's what you picked.
They may be okay with 10, but you can't say that was 3 kilometers, you can't say I was only going 107, because you were trying to go 110 and the wind affected it.
Yeah,
Yeah.
that's fine.
So even when because your speedo reads how fast you're moving, isn't it?
Yeah, it rebounds back. So like the radar gun, it's basically, it's very similar to sonar. It hits and it sends a signal back, and how fast, the difference, so it'll send it back and then it'll calculate it and then it'll send it back again. And that's the difference, right? So that tells you how fast you're going. Okay, but, hello. Okay. Hi. Hi. More than enough. She didn't know. She said it's music horrible, so she didn't really know. Maybe ask, I don't know, you can contact the school, but that's all I got is your phone. Okay. Yeah, I'm not sure now.
Calculates your speed as well.
Okay.
You would show that person going 200 kilometers.
Okay. Alright, so did your question get answered?
I'm still kind of confused that like on a car's speedometer, doesn't it show the exact speed of the car?
that the car's moving, yeah, but it won't factor into the wind. Like if you can tell, you can tell when you're going into a wind and when you're going with the wind,
Yeah, but
okay? So the
Then-
speed,
power compensates for that, and then you just have to increase your power to maintain the same speed. Don't you?
oh, there's still gonna be a discrepancy there. I see where you're coming from, because if a car is going up a hill,
Right, you're still going 100 miles an hour.
no, you're gonna go slow, but then the car is going to compensate for your
Yeah,
lack
that's
of
it.
speed.
That's what I mean.
It's gonna go, but there'll still be some, it's probably negligible that it's gonna pick it up on radar. Okay, like, we're not talking, that's what I mean, like, an airplane that's moving at 100 kilometers an hour going this way, and the wind is 50 kilometers an hour behind him, he's not going 150.
No.
Right, because there's still aerodynamics and everything that factors into it. But there is still going to be some, what you'll find is the gas mileage that will be affected, because it's moving you and the car's having to work less. So it does, yes, you're right. It should factor in the direction of the wind, but there will be some play in there, but it probably isn't much more than a kilometer.
It won't affect you enough that it's gonna make you get a ticket for it though.
Yes.
So basically what you're saying, like, as long as the car maintains the same amount of power, that's when wind affects it, because,
Yeah, it would have to, it can't adjust for it.
yeah.
That's right, yeah. Okay, is there any other questions out of the book that you want to look at today?
I still don't know how to read the football question.
Okay. Football question, quarterbacks run across the field parallel to the line of scrimmage. Okay. I explain this every year because nobody loves football near as much as I do, so that's fine. Okay. So let's say there's another question like this, and it's a bike question where a kid's pedaling a bike and he's throwing a newspaper. Okay, so if I'm playing catch with this guy that's across from me, and I throw the football straight across from me, we have no issues. But I got a guy chasing me, so I'm going to be running in that direction. So there's two things that can happen here. If I'm running in this direction, and I wait until that guy is directly across from me, and I throw the football, is it going to go straight at him? No, because he has to take, the football itself has to take up my speed that I'm running horizontally. Alright, so if I threw it across from him, it'd be just like, it's the same as a current in a river, right? I could paddle straight ahead, but that current's going to move me. So, what do I have to do in order to get the football to go across from me? I have to throw the football. If I throw it, I have two choices. Throw it before I get to the guy, so I could throw it from right here instead, and throw it straight across, and then he'd end up over here, right?
Yeah.
But if I wait to get straight across from my receiver and have to throw the football to him, I have to throw it back this way. The same as the question yesterday, where I have to swim back into the current. So the horizontal speed that I'm running at is that right there. The speed at which I throw the football is that right there. Okay? So reading this question, it says, a quarterback is running across the field parallel to the line of scrimmage. So this is what we consider my line of scrimmage. He's running at a constant speed of 2.5 meters per second when he spots an open stationary receiver straight downfield from him. If he can throw the football at a speed of 8 meters per second relative to himself, at what angle relative to the sidelines? So if this is the line of scrimmage, that's the sidelines are over here. Okay? So the vertical is what I want. I want that angle. Okay?
Which guy has the door open?
This guy. He's got a football. Okay? And what must you throw it in order for the receiver to catch it downfield? How far downfield was the receiver if the pass took 3 seconds to get to him? Okay, so here's the time right here. There's 3 seconds it takes to get to him. Okay? So the velocity that he throws it at is 8 meters per second here. The velocity he's running at is 2 meters per second here. Okay?
Good. 2.5
Is
meters.
it 2.5? Way faster than I thought. Okay, 2.5. You understand that? So this question is exactly the same question as the swimmer going into the current and wanting to end up across from him. Do you follow that, Mary? Is there any part of it that you don't understand?
Just like the drawing, it makes sense.
Okay? Now, there's going to be another one where, in that book, in that review, where a kid's delivering papers. And it says, if he throws the paper to the porch, how far ahead of the porch does he have to throw the paper? Same question. The important part is, in this question, this is the speed at which the ball or the paper moves at. This is the speed at which the person swims in still water. This is the speed at which the boat goes in still water. Alright? Now, are you going to, is that ball, is that paper, is that swimmer going to be moving slower or faster than what he actually can?
If he's running forward or back?
Back. Slower. Slower every time. This velocity right here is what it's going to appear to go at. This will be slower because there's your hypotenuse. There's at least 5 questions that are done the same way. You will see one of those 5 questions. So make sure that we understand this concept here. Okay? Are we alright? Mary, you better? Okay? Anybody else?
When do you think we're gonna test them?
Next week.
Day next
I don't know.
Mm.
I know French go Thursday, so it'll be before that.
Yeah, I remember seeing some passport was missing Thursday.
week. Could we do it on Wednesday?
So you're probably looking at a Wednesday test next week. Okay?
I hate to say this, but that question seems a little, I don't know, it seems to confuse me a little bit, I don't know why. It's just, I find when you talk about a river, it seems easier to understand, but when it comes to throwing a ball, I don't know. I'm trying to understand how that would work.
Okay, Morgan. I'm running. Okay, see that black poster?
Yeah,
Okay? So, if I'm standing across from it, Morgan, I'm going to throw this pen at it at 8 miles an hour. Okay, or 8 meters per second, my bad. 8 meters per second, that's how hard I'm going to throw it, right? So I can stand here and I can throw it straight ahead of myself, I'm going to hit it. Okay? You follow that?
Yeah.
Alright, well what if I'm running? What if you're chasing me down, because you don't want me to throw your favorite pen, and I'm going to throw it? Am I going to hit it? As I'm running this way towards that wall, and I throw it right from here, am I going to hit it?
Straight across from there, no, you have to throw from there, diagonal.
No, I'm going to have to throw it from right here,
Oh,
straight across, because the pen is going to be moving at the same speed as me.
Can you try
No.
that? Why?
Can we
Just
see if
let
we need
Lexi
to
go
throw
stand over
one?
there.
You follow this, what I'm saying.
Visual.
Okay, I have to throw it, but if I want to throw it at it when I hit straight across from it, I have to throw it back at that pole. And then it's going to slide this way because it's moving at the same horizontal speed as me. Now let me put this into a different perspective for you. If you're driving in a car and you drop this out, is it going to hit the ground straight above you?
no,
How come?
because you're moving.
Exactly. It's going to end up over here. Even though I dropped it right here, because the car is moving, it's going to hit the ground right here.
Yeah.
You follow that?
Yeah.
Same thing. If I throw a ball, okay? If I throw it at it and I'm running, I have to throw what we would call behind it.
Yeah.
Okay? If this is the guy right here, we say that we have to throw the ball behind the receiver so that the ball can loop over to him. You follow that?
Yep.
Okay? That's if I throw it straight across from him. Okay? If I want to hit that receiver while I'm running in that direction, okay, I can throw it straight ahead here, and it's going to end up over there at the same time as I end up straight across from him.
Yeah.
If I throw it early, meaning before the receiver, if I throw it here, it's going to end up at him the same time I get here. You follow?
Yep.
Okay? The point of it is, the frame of reference is the ground, and I'm moving on the ground. So the ball is moving. As long as it's in my hand, it's moving at the same speed as me.
Yeah.
As soon as I throw it out of my hand, okay, the ball is still moving the same speed as me. You understand that?
Yeah.
Okay? So I have two choices. If I'm standing straight across, I throw behind me so that it ends up straight across. If I wanted to swim to that black poster and there's a current moving this way in the room, I have to swim that way so that the current moves me back this way.
Yeah.
Means the same thing. You get it?
Yeah.
You sure?
It's more clear than it was before.
Okay. That's all I can ask for. Alright. You have the rest of today. Continue to work on it. At the end of class, I'll give you an assignment for the weekend. It's up to you. You want to turn it in for marks? I'll mark it. You don't? That's your choice. Okay?
I actually do Wednesday, so by Thursday.
So you'll rate it Tuesday then?